Everyone, please take your seats. Please take your seats. We're starting. As people funnel in, if there's not enough seats in here at any point during the conference, there's overflow upstairs in room 302 and 306. They're really easy to get to. You take the elevator to the third floor and the room is right there, or it's at the end of the hall on the other side. But we should be fine for now. Thanks.
Okay, thanks, Morgan. Hi, everyone. I'm Ursula Howson. I am with the Office of Renewable Energy Programs and with BOEM. I am a fisheries biologist, marine scientist by training. I am now a policy analyst with OREP, we call it. You may hear that this week, Office of Renewable Energy Programs. And I'm here to introduce Dave Bethoney. He is the Executive Director of the Commercial Fisheries Research Foundation. He's been the Executive Director for about 4.5 years, and he is going to present on engaging the fishing community to improve marine science. During his talk, please feel free to submit questions, and then when he's finished, I'll start fielding the questions to him. Okay? Dave?
All right, thank you very much, Ursula, and thank you for the organizers for this conference for giving me the opportunity to come here today and talk to you really about the foundation that I run. And the specific ask was to talk about how to engage fishermen in marine science and not necessarily about offshore wind, though we will talk about that to some degree. So what I've done here at this presentation, I'm going to talk a little bit about the foundation, and then we're going to touch on a variety of different projects that shows different ways we've engaged the fishing community, but it's all going to be kind of framed into one context where I hope we can take away, a message about how to work with the fishing community to conduct science and really community engagement in general. So to begin, just wanted to tell people about the foundation here and where we are. So we're located in southern Rhode Island near the point of Port Judith, and right across from Long Island Sound from where we are today. And where we are based out of is the University of Rhode Island Kingston campus, and they let us use this building here. So we are not part of the university. We're our own independent nonprofit, but the university gives us this space with very little overhead. They take care of the building for us, so it's a really important partnership for a nonprofit like us to have that taken care of. So we appreciate that level of partnership from the university. What we do there, our mission statement is shown here, but really we were founded by the commercial fishermen from disaster relief money about 20 years ago, and what they wanted to create was, instead of investing it back in their business, was to invest it into alternative or complementary science. So can we create an organization that serves as a catalyst between the fishing community and scientists to work on certain goals here? So those bullet points, the large writing under the red there, that's kind of our work areas here. We're trying to fill data gaps. We're trying to create opportunities for the fishing industry, so there might be difficulties, do that research and development to help them communicate science in a less complicated way, and then engage students to help with the next generation of fisheries scientists, know that you can work with fishermen as part of your training. It's not a foreign concept. So, this is not for you to read all of these vessels. It's to show that we work with a lot of different fishermen in a lot of different subject areas. So over the past 5 years, we've worked with 98 different fishermen in a lot of different ways. So we're engaging the community, a lot of different ports up and down the East Coast, and then we're also working with a lot of different organizations. So these are not the funding organizations. These are organizations that serve on advisory committees or are co-PIs on projects. So we have a lot of different fishermen, different subjects, a lot of different organizations, and we're trying to get them to work together to do science. And what we didn't do intentionally, but what I've come across about a year ago when I was at a meeting that wasn't about science, it was more about being a director of a nonprofit, is that a lot of our work can be framed as in the collective impact approach. So what are we doing? There's 5 basic things for this approach that nonprofits use to get people to work together. So this is from the United Way website. And when I thought about our projects, this really struck to me that a lot of what we see here listed out, there's elements of it in our projects. We bring people together from different communities to create an agenda. We agree upon what we're going to do. And then really these mutually reinforcing activities, this constant communication, this backbone support really come together through executing that measurement plan through several years. So I'm going to give examples of projects and try and frame them in this way a little bit, but then also just try and highlight different components of collaborations from these different projects I think are important. So the first thing we try to do is help fill data gaps. And to explain that, I'll give an example from one of our flagship programs here. We call it the Lobster and Crab Research Fleet. And what this essentially is fishermen taking measurements of lobsters and crabs. But how it started was through this common agenda and recognizing a common data gap. So in this figure here, it's a snapshot in time from about 10 years ago about pot trap landing. So it can be a proxy for lobster fishing or crab fishing for this purposes. And you see that the more yellow or red, that's the more intense effort. So a lot of it is inshore, but then on that Georges Bank, the bottom of the map closest to me, you see a lot of yellow there as well. So a lot of effort in these offshore regions, but not a lot of information for science. All the surveys are conducted close to shore, and then the observers that are taking this data, they're few and far between on these vessels. So there was this data gap and then an agreement that we should empower the fishermen to fill this data gap. So this is it written out in the stock assessment terms, is basically they need offshore data. So we have this picture here. This is from that very first meeting about 10, 15 years ago now. And what it embodies is there's fishermen, there's scientists, there's managers getting together, deciding, what is this common measurement? How can we work together to empower fishermen to fill this data gap? So what they came out with was a set of tools here. So one of the most important things for us has been this tablet application. It's called On Deck Data. And what it allows fishermen to do is easily record data, way easier than trying to have a pen and paper out there. So we're reducing that burden of tracking, of typing in information. We're giving them simple tools like the calipers to measure the animals, ventless traps to capture smaller lobsters, and then importantly to compensation. So we're basically asking them to do a job on top of fishing, to be a scientist or to take scientific measurements while you're fishing. So we think that agreeing on compensating the fishermen to do this is an important tool. So we were going to ask them to collect that biological data and then also data on effort. And these are just some pictures about the app itself, what it looks like, and then environmental data also trying to be collected through a separate application. But the point is giving the fishermen the tools to collect this data, and the app also directs them on how to collect the data in a scientifically rigorous way. So what was that? The activity, that communication, that backbone support. So what it entails is us going out, training the fishermen on how to collect this data, always being there as a support when they run into problems with the app. So we provide that initial support, and then we're there as well to help troubleshoot. But it's up to them when they're out fishing to collect that data. So they do that when they get back to shore. They send information back on that tablet when they're connected to Wi-Fi. It goes back to our data set where we do quality control. And then importantly, that continuous communication, we're giving the data back to them. So all their data that they collect, they can see, we make some figures for them, and they have access and data sharing to what they've done. We also send it to state and federal databases to be used for that initial purpose in the stock assessment of lobsters. So how did we end up? Did this work out? So it really has. So we've engaged, over these 10 years. This started in 2013, so we're beyond 10 years now. We've had over 40 different vessels participate. We have an active fleet of around 20 vessels. These hashed areas that you're seeing are all the different statistical areas or regions of the ocean where the fishermen have provided this data. We've expanded through the years on the complexity of the data they've collected. So adding things like egg stage and shell hardness stage, those are all things that evolved over time and were added through that type of feedback. Some of it comes from the fishermen interest, but some of it comes from the stock assessment and scientists of, hey, presence absence of eggs is great, but do you think the guys can actually give us stages of eggs? And we say, we'll test it out. And that's been successful, providing those pictures that you see there so they can match that up and increase the amount of data that they've collected. The yellow dots I showed were temperature monitor stations. So we have a lot of temperature readings as well. And then, just importantly, that after that first initial wave of data, this was a report from that next stock assessment that happened after that. And it's essentially, 3 million pounds of lobsters would have been unclassified. They would have known the size, the sex ratio, the egg-bearing stage of those lobsters without the efforts of these fishermen. So it's been a great success in those terms. I think a model for engagement. And, once you get past 10 years, you can start doing a lot more than what you initially wanted. So we have a series of publications that extend and look at questions beyond the initial goal. What's the impact of the marine monument closure? Has the size of lobsters that are mature changed over time? So those are kind of broad questions that come through scientists and managers. But then there's also the questions that come from the fishermen themselves. So one particular example is a bay fisherman. So a important bay for us is Narragansett Bay in Rhode Island. He noticed that more and more lobsters were having more and more shell disease, and he thought smaller over time. So we can look at that for him. We can look at that in a scientific way. That's what this figure is showing here. Vertically, it's the amount of it's a proportion, of shell disease. The different colors are the shell disease severity, with red being the most severe. And you can see, his observations match reality from the data, from a wider set of fishermen, not just him. And then we can compare that to that whole data set, and you see that trend does not occur like that in the whole data set. So there's a regional difference here, and we can look into this information that he really was curious about in a way that is very scientific and rigorous. So with that, we have a lot of other examples similarly where we've looked at other species in the same type of model and trying to improve the data gaps there. And I do want to just spend a little time. I know Dr. Garkowitz talked about this in the plenary, but all these top three here in the lobster crab, that's fisheries focus, answering a question that helps scientists assess those populations of animals. The shell fleet is a different way to engage the community. This is trying to help understand the basic underlying oceanographic processes that are causing change, specifically in this region that you're seeing here, just south of Rhode Island and where we are today. So we have the fishermen. They're seeing different species of animals. The timing of the animals coming and going is different. You have oceanographers who want to link their observations to the fishing industries. And that's where we came in with this shell fleet, is getting guys out there to take measurements and being a catalyst for this communication. So, I won't go into this because Glenn showed a lot of these processes here, but of particular interest were these influxes of salty, warm water that we thought were changing the way species came into our continental shelf here. So the agreed upon measurement was these CTDs, or conductivity, temperature, and depth probes. And how are we going to get those measurements? Once again, we were going to give the fishermen the tools to do that, a tablet, the probe itself, and to make these casts while they're doing their commercial fishing activity. So what the result of this has been, we've had these activities ongoing for over a decade. Almost 1,000 profiles have been collected. The range has expanded, so we're outside of that box in this figure. But even more so, we have guys from New Jersey collecting data. There's a pilot fleet off of Cape Cod trying to engage fishermen this way. So that type of model of getting fishermen to take oceanographic measurements has expanded. And that's an important thing that we want to see through engagement, is it's growing to other regions as well. And really, the best part of this has been that continuous communication and support. So not just us, once again, talking to the fishermen, but also being that link and having Dr. Garkowitz, come down to the ports, come onto the vessels, talk to the fishermen, explain, how what they're seeing might link to the oceanographic processes that he knows about, that he's seeing in the measurements that they're taking. So that communication part of it is key in that feedback of seeing the data you're collected, given back to you in a way that's helping you understand, in this case, the environment around you. So, and I just, the results too, you don't have to take my word for it. There's 6 journal publications that have used the Shelf Research Fleet data to explain things like these increases in salinity max intrusions or marine heat waves. And then it's also helped us better understand, how to communicate, integrate fishing industry knowledge into oceanographic understandings. Should have got some water here. So that's basically how we are engaging the fishermen to fill gaps by empowering them to collect data during commercial fishing activities. Another set of do this is to help use them or advocate for them to be used as research platforms for fisheries independent projects. And really, most relevant to this group and to our foundation in this subject has been fisheries monitoring and having fishermen be involved in these fishery monitoring plans and execute the research. So, I would say that there was a common agenda that the developers that we've worked with did want fishermen to be a part of it. There was a lot of hurdles and a very complex middle, but the results have been positive. So I'm not going to differentiate this from the next session. I'm not going to go into that. So if you want to hear more about that complex middle, come to session 5 in the auditorium. You have to listen to me again talk about wind farm fisheries monitoring. So I'll move to kind of a different area altogether. So those 2 examples are about collecting data to improve, monitoring and biological assessments. Another component of the foundation, how we're engaging fishermen, is through creating opportunities. And, conservation gear engineering is a term that I should have removed it. It's really gear modification is an area that we do that. So working with fishermen to adapt and adjust their gear to better achieve, sustainability objectives or fishing objectives. So we have a lot of different projects that do that, but I want to emphasize one in this kind of, collective impact format of how we're doing it. So the scallop fishery is one of the most important fisheries in the United States. It's something that both fishermen and managers want to see is a reduction, and thank you very much, Morgan. I appreciate it. So it's to protect juveniles. So what the fishery does is it closes certain areas, waits for the scallops to grow, and then reopens them. So what you're seeing here in this figure is from the Virginia Institute of Marine Science survey from an area that was just about to be opened in the next following months. So you have these really small scallops. You see that on the slide furthest away from me. And in that same area, you see that there's a presence of bigger scallops. The blue line is the survey data, and the red line is the commercial fishing data. And you can see that red line, there's a whole bunch of blue, less than 100, but there's also the commercial dredges catching these small scallops too. So is there a way to reduce the impact when you're fishing in these mixed areas so you're not bringing up small scallops as well as those big scallops that you want to fish? And then similarly, another small animal that scallopers want to get away from are sand dollars. So this figure here, the darker it is, the more sand dollars there are. And in those really brown areas, they basically can become an inability to fish there. So you start getting tows like this, where you're just bringing up a whole dredge bag, a hole full of scallops. You're filling it up to the rail. You can't fish there anymore. So if areas like this are off limits, you have wind farm development that you're not sure about you're going to fish in, your area is getting tighter. So how can we give guys access to these grounds? So our idea with working with commercial fishermen was to explore a bigger ring size. So this is what commercial fishermen, scallopers use. It's a bag basically made of small metal rings. So that's what you're seeing there. So if we make that ring bigger, you're going to lose scallops, but maybe you'll also lose small scallops and sand dollars and retain big scallops in a way that's still commercially viable. So that's what we seek to do in this project. And, we took that typical scientific approach where you have a vessel on one side, it's the experimental dredge, on one side, it's the normal dredge, and you do your 100 or so paired tows for comparison. But the real engagement part of this came from having the fishermen be involved in the initial development of what we're going to do here. So we had a 2-day trial where you could just take out the experimental gear, take out what they normally do, their normal adjustments to get around sand dollars and small scallops, and spend 2 days just messing around with the gear and come out with what you think your best tool is. Because that's something that we saw as a pitfall to a lot of these gear modification studies, is as soon as you get out there, you do 5 or 6 trials, and the fisherman's like, this isn't going to work. And then you're like, well, we have to do a 50 paired toes to make our scientific sample size. And it's just like, you just disconnect. So let's remove that and have a whole trip where we're just trying to come out what we agree upon is the best tool. Because a lot of things change between paper and on the vessels there. The other part of it is really incorporating fishermen feedback in the results interpretation. So not just relying on statistical differences, but how does that turn out for you in practice? So if we have a result like this, and then it turns out like this, and there's significantly less scallops, that still might be valuable to a fisherman, because he might say, I'm not going to fish in an area where it turns out like this. I'm just going to abandon it. But even if there's significantly less scallops, I could still work this area. I could still fish in it. So we're not just having that scientific results, but also incorporating that results that are important for how to use this tool in practice is what I wanted to highlight from that. So we're still working on this project, but we have some work that we think could improve it already. Another way that we're trying to create opportunities with fishermen is to look at species that might be considered bycatch or pests and see if they can be turned into a profit. So that's the tagline for this project about spider crabs, from pest to profit. So spider crabs are an inshore crab species that our state water lobstermen encounter with a lot. So basically they fill up the traps instead of the target species, American lobsters, or rock crabs or Jonah crabs, and then their long arms make it difficult to get them out of the trap. And then this is a trawler who is definitely not targeting spider crabs, but is inundated with them. So there's no assessment for this, and there's no market for this. So in trying to be, a scientific organization, we wanted to do some data analysis and see what was out there before, it's this pickle where it's like you don't want to create a market for an animal that doesn't necessarily have any idea with how it's going to take fishing impact if it takes off. But then no one's going to be interested in doing an assessment of an animal if there's no real fishery for it, unless it's a protected species, which spider crabs are not. So that's the gap we're trying to bridge here, interviewing the fishermen that encounter these, working with the University of Rhode Island to try and develop product from these animals, which they have been successful in doing, and I'm happy to talk more about it. But just another example of engaging the fishing community to try and turn something into a problem to an opportunity, and then thinking about both sides of it, not wanting to over-harvest it, but also needing to create a demand for it and a market for it. So finally, wind farms. So coexistence with wind farms has been a big area for our foundation in the last 4 years. We've kind of come to the realization, several years ago that wind farms are going to be present in these areas that the fishermen that we work with fish, so we need to figure out how to access these areas. So one thing that we've been working on has been mechanical jigging. So these machines, they could harvest potentially fish from artificial reefs that are created by wind farm turbines, in an economically efficient way, perhaps faster than rod and reel. So really, the agreed upon agenda here, from NYSERDA, the funder of this, from developers and state agencies that are supportive of this, is can we reduce the research and development burden of figuring out how these machines might work near wind turbines? So that this project is about is trying out these 3 different machines. The first year is just working with the fishermen to try and optimize them, and the second year of the project would be more of that rigorous comparison of the catch. And what I wanted to highlight from this is kind of that engagement again. So how is this a different level of engagement than the other projects I've talked about? And here we went, instead of trying to find one expert hook and line fisherman, we tried to get a diversity of fishermen to represent the different sectors that might be impacted. So we have a lobsterman that's interested in, hey, can I use this to supplement my income? We have a charter fisherman who's interested in using this between charter trips. And we have a hook and line fisherman, a commercial hook and line fisherman, to help us understand how it's different from that practice and how it might be deployed by him. We also recruited some experts who are expert jigging fishermen to be kind of consultants on this. And then finally, it's not just about working with the fishing community, it's also working with the broader community. So there's an advisory committee of the developer of Block Island Wind, Ørsted, and then also state and federal agencies too, to help us, really figure out, can this be a viable alternative gear? And then last, I just wanted to touch on a project that kind of brings the three themes that I talked about previously together. So that's automatic squid jigging. So if you look globally, how are squid caught? They're caught with automatic squid jigs. Billions of pounds of squid are caught this way. Here, it's trawling. Recreational is jigging. If you want to be a commercial fisherman, you trawl for squid. So is there a way that we can import this knowledge to help, address some current challenges? So the longfin squid fishery, they're only harvesting all of their quota about 30% of the time that they can. So there's a way to increase capacity before this year in the fishery that way. The catch has been low this year. But bycatch is a concern in the squid fishery with this trawling having about 30% bycatch rate. So how do we increase capacity without increasing bycatch? Jigging is a way to do that. It has very low bycatch. And then how do we deal with, if your offshore wind farms are probably going to be very difficult or impossible to trawl in. So how do we increase access into those areas? Or closest to me, what that figure is showing is a network of closures where you can't access if you're trawling. There's other squid fishing grounds that are off limits to trawling because of those bycatch concerns. So jigging, maybe in wind farms, but certainly it could open up other areas of the fishery that are off limits to trawling for access. So what are we trying to do? We've taken a twofold path here. First is we've created a lending program. So we had a typical grant to do, bycatch reduction engineering program to see if we could get these jigs that you're seeing here to work. After that program finished, it was this typical situation. If you have this gear, what do you do with it? It's going to sit in your basement indefinitely or sit in storage. So our idea was to get this into the hands of fishermen that might be interested in using this type of fishing activity, this gear. So what we've done is taken the lessons that we learned, we work with fishermen, we ask them to do semi-structured data collection, we give them the machines. Again, we're that continuous support. If they need help, we can help them. We can buy stuff to modify their vessel for them and really try and put it in their hands to test out the gear when they're fishing. The other way we've done it on kind of a larger thinking scale is international exchange. So, we engaged the Japanese fishing industry. So Mr. Hamano there, which is closest to me, he is from the Japan Fishing Machine Company. So he's interested in finding a new market for his jigging machines, which are shown for me. We have the Town Dock, which is one of the biggest squid harvesters in the United States. They're interested in this technology. And we have a developer, Avangrid, who is interested in supporting this as an alternative gear type. So bringing those three parties together and trying to, have the Japanese fishermen come out here, teach our fishermen how to use this, give us this gear, and then hopefully we can continue on from there. And then the meaningful support, from a wind farm developer says a lot about this could be a potential way forward. So a couple more topics to discuss. So those are all, research activities, how we're involved in research, how we're getting fishermen involved in research. Another component of engagement is communication. So we have projects that are dedicated to just science translation or trying to communicate, information to fishermen. So one example I want to give on that is ocean acidification and the scala fishery. So we had an interdisciplinary team that was interested in engaging the commercial fishing community and talking to them about how their models are projecting ocean change, how they might help fishermen develop resilience to impacts on scallops from ocean acidification. And our job was to take slides like this and not have them shown to fishermen, because this is a complicated slide that is not going to be, your message is going to get across. So we are playing that community engagement role, trying to take a relatively difficult topic and have it understood by fishermen, not just for their benefit, but for the researchers' benefit as well. So that was our role in this project. It's still ongoing. We took a multidisciplinary approach, so there's an economist on this, there's social scientists, there's modelers, there's biological scientists on this. We did kind of the typical making flyers, making outreach documents, but I think what was really most effective is dedicating to 3 times a year having workshops in the fishing community that really evolved from this basic lecture, question, answer when we first started, but then as we got feedback from the industry, evolving into more of whiteboards and open discussion, and coming back the next year and having answered the questions that were brought to us that previous year. So it's really that, again, that continuous communication, that backbone support is making the commitment to come back to these ports, 3 years, and we'll have a 4th year of this, to show that we are listening, the project is changing with your feedback, and we are trying to make the results practical and accessible, and we're not just gone after one lecture, never to return. So, and lastly, Dr. Secor, David, you brought up this, science, student engagement, and trying to get that next generation of scientists here and working on fisheries and working on collaborative research, is a challenge that the foundation recognizes, and it's something that we try to do. So it's not just these typical seminars and university collaborations, but also it's direct student engagement. So these are students that the foundation is directly funding through our grants, and we have 5 or 6 active students right now from different universities. URI is always a good presence because we are just in the community, and it's really important for us to show young students what we're doing as a model, so they can go into their careers and really help address some of these problems and areas that we're seeing with the perspective that it can be done with the commercial fishing industry. So with that, thank you. What is my message is it's take away, the specifics from our foundation that I try to provide example is that, you have goals, and if you can find a way to do science and community engagement, for us, I think this framework really helps us understand that, but it can be a different framework. But what you're trying to do is get your goals out there, and you're doing it in collaboration with many different users that you might be impacting or working with potentially, and then creating this continuous discussion, continuous evolution, and then you'll see effective results. And it's really that growth that's important, and that will keep you getting the money too. So, and with that, none of this is possible without the funders of this. The projects I showed were some of our active projects. The funders are shown here, but we do a lot more than I showed here. And with that, I'll take questions. And thank you for your time.
Thanks, Dave. That was a great presentation. Just a reminder, you can submit your questions in the CVent app. That's how we're going to be fielding questions. We already have a couple of them, but I think we may have time for a few more, so please feel free to submit those. Let's see if I can read these. Is that on? Okay, Dave, on average, how much more time is added to a day of fishing if the fisherman is taking data?
So I think it depends on the program. So that lobster crab one, that can add, it depends on, it can be like anywhere from 30 minutes, I would say anywhere from 15 minutes to an hour or more. It depends on if they're doing it by themselves, if they're working with one of their crew. A lot of the guys, like in those pictures, there's 2 guys collecting the data. And then some of it can be relatively simple. your hauling gear. If there's a target number of traps that you're supposed to sample, if there's nothing in those traps, then it's not a lot of time. But it's hard to answer that because it depends.
Okay.
But it's not like half a day.
Okay, so it's manageable.
Yes.
Tends to be.
And then most of these programs have different tiers where you don't have to do the full sampling to earn a stipend. If you choose to do half a sample, you can get half a stipend. You can get quarter stipends. So you can kind of pick and choose when you sample and how much you sample.
Okay. Can you share what some of the spider crab products are? Have you eaten spider crab?
Yes and yes. So the spider crab, we are working with Dr. Chong Lee and his students at the University of Rhode Island, and what they have is a deboner, and basically you can put these crabs in there and it squeezes out the meat from there. Sounds nasty, but then they take that base product and they've made crab dip, which was good. They made crab fritters that they served at Eating with the Ecosystem, which is like a local group that does a lot of great outreach, trying to get people to eat, sustainably and locally. So we were part of one event where we served these spider crab fritters to a whole group of people and seemed to get good feedback. We had another event where they made patties, like crab cake patties. So the idea is to use, this slurry, this gup as a base to make other products rather than trying to get people to want to pick apart a spider crab like they would a lobster or a Jonah crab.
Just the legs, or are they able to get any of
They
it?
did the whole animal.
They do?
Yeah. So there's,
How can fishermen get involved with CFRF and become part of a sensor fleet?
So we have a newsletter, not newsletter, like a listserv that is on our email, on our website. It's one click to sign up. So then you'll see all our opportunities, and you can also come talk to me. But really, it's just word of mouth is a lot of it, and then getting on that communication list.
Okay, great. These are great questions. Have you seen evidence that your science communication efforts have been effective?
Yes. So I'll stick with, I guess it depends what you want me to talk about as effective. So for science communication, I will say effective is that you're modifying your science in a way that improves the project, and then you're getting fishermen to engage, to come back year after year and be interested. So from the ocean acidification project, we had, you saw one of those pictures where there was different types of shells. So we had fishermen touch shells, and one was grown in an acidic environment, one was grown in a normal environment. And then that led these guys to saying, there are shells that we feel this way. We don't know if it's ocean acidification, but we know that they've been getting thinner through time in certain areas. And now it's created a whole other side project where the scientists are looking at shell thickness through time, and it's coming through where there's areas where shell thickness has been decreasing through time. So I think that engagement helped the scientists. And then on the other end, particularly in the New Jersey Barnegat Light, we have a group of like 15 fishermen that came to the first workshop and have come every year since. So they're coming back year after year, which shows me that the engagement is working.
Yeah, that's great. And are they then bringing back shells? I mean, is that the whole...
Yes, so initially it was the scientists were working at the shell archive from the Science Center's survey. And then recently we got a scallop funding for the fishermen to do just that. Okay. So now they're going to take that historical database, and then they're going to have fishermen collect shells from different regions, contemporary, and compare that.
Wow, that's great. Okay, next question. Are there commercial fishers in the region who are anti-CFRF and do not want to participate, or do enjoy universal acceptance?
So,
depends if offshore wind is involved, I'm sure.
Yeah, that was definitely a divisive area. I never had somebody not understand what the foundation is trying to do and say that, this is worthless or we don't like you. The difficulty that we have is, not becoming an exclusive club. So I've heard that criticism before, and it's difficult because there's guys that and you start to work with them over and over again because you trust each other, because building trust is what this is all about. But then you have to create avenues for new fishermen to be able to get involved. So we try to do that by when we get new projects that aren't an idea of one fisherman, that would go to him. We try to send out solicitations on that listserv so everybody can apply to make laminated flyers and tack them down the docks, and then we kind of vet it through our board and keeping that in mind, trying to get new people involved.
Expand.
Yeah, and then but the wind farm thing was definitely, when we started doing wind farm research, there was definitely some pushback there about that.
I think you already answered this about getting compensated, or fishermen compensated for their time collecting data.
Yep, yes they are. Yeah. So it depends on the project. It depends on what they do within the project as well. I will take that question as like a public service announcement that, one thing that we definitely try to do is when you have a meeting where you're trying to solicit information from fishermen, you're treating them as experts and trying to get information that you should consider you paying them for their time to be there. We all get paid to sit at this type of stuff, but fishermen are coming during their own time, their off time. It's not their job. So, we really advocate for that. If you're trying to have an open workshop where it's just informational, it's different. But if you want to invite fishermen to be experts on subject matter, you should compensate them.
Well, and they could also be losing out on a day at sea.
Right.
Yeah. Okay, we only have, I think, about 4 more minutes. Cooperative research relies heavily on trust and relationships. CFRF, and you, Dave, in particular, have well-established relationships and trust. Can you provide thoughts or advice on how to build trust?
Yeah, so I think the number one thing is that continuous communication. So I know it's easier said than done, but trying to be responsive to questions, trying to follow up if somebody asks you something and not ignoring them. And then, if you have a project with the fishermen, this data sharing part of it and involving them from the design to the end is really key in building that. So you could say like the process is a result to build trust, and not just treating them as your charter for the day.
Because you're going to be potentially working with them.
Yeah, if that's your goal, then that's what you should treat them that way. But it's really being present and open is the number one thing.
Good, thanks. I think this might be the last one. Well, maybe 2 more. Let's see. That has 4 votes. What is the QA/QC procedure for the data collected by the fishermen?
So in general, they upload the data. It goes through our database. Then there's a series of like scripts that we run, like size, depth, all kind of like typical ranges that if they're submitting data that's out, without it flags it. And then we follow up with them, was it a mistake or was this actually an outlier? So that's probably the number one way that the QA/QC is done for that data.
Great, thanks. And okay, does CFRF provide fishermen with the opportunity to attend and take part in scientific conferences, possibly through sponsorships or covering registration fees? Is this a viable way to increase communication and awareness and interest?
I think it is. I think it's something that the foundation is starting to get involved in. We recently had a workshop with the University of Rhode Island where we were able to offer fishermen stipends to come and attend that workshop, and the whole idea was to facilitate communication with European wind farm experts. So I think that was a great example of what we just discussed there. And then there's other examples, like the American Fisheries Society has a stakeholder day where I think they provide funds for some fishermen to come. So the foundation we've been talking about, should we maybe contribute to that section chapter with the stipulation that you're going to use our funds to help fishermen get to the stakeholder engagement day. So that's, yeah.
Great. Okay. Any last words? You have a minute.
Thank you very much for the opportunity to come here and talk for 45 minutes about the Commercial Fisheries Research Foundation. And if you have any questions, let me know. I'm here till Friday.
All right. Thanks, Dave.